Hi there. So the last video finished up with the clock is built but not running properly, and there were various problems that I identified that needed to be fixed. So since then I've been working on resolving those issues. So let me show you where I've got to. I've added a drawer down at the bottom of the clock which houses an Arduino microcontroller, which has a data shield mounted on top which collects data to an SD card. It's connected to an environmental sensor that picks up temperature, pressure and humidity, and also connected to this beam break photo sensor here, which is triggered by the flag at the tip of the pendulum. So this lets me pick up the behavior of the pendulum and the temperature and pressure that's associated, which will let me adjust the temperature compensation and the air pressure compensation that is built into the pendulum. I'll do a separate video about this Arduino and setting it up in order to do this. Having identified that there are some problems with the meshing of the gears, now I'm checking each gear pair in turn in the frame, just looking for any slight binding on the gears to see where the problems are. And once I've found the binding, I just file off the gully to deepen the gully, perhaps to make the meshing work better. Now that all the gears have been adjusted and the engagement has been corrected, the teeth have been filed, the gullies have been deepened. So now what I'm doing is putting each of the gears one by one into the frame so that I can check that everything appears to run correctly, and also to move the gears on their arbors up and down so that the wheels run in the middle of the pinions. Once all the gears have been put back in the frame, the heights on the position on the arbors has been adjusted. We've now got a complete working gear train all the way from the great wheel at the bottom up to the escapement up at the top. And if I apply pressure to the great wheel, just as the weight would do, then we can see that the whole train turns and everything starts to move. Unfortunately, when I was checking the engagement of the gears, there seemed to be more friction in the gear train than I was expecting. And eventually I tracked that down to one of these shafts was not perpendicular to the back frame. If you line up the shaft with a perpendicular, it wasn't actually perpendicular to the back frame. So that meant doing some additional checking to see whether these bearings were actually in the correct place. And yes, I did have to move one of the bearings. After that was done, I then checked to see that each wheel was running properly. Here's the escapement wheel and the intermediate wheel, and the minute arbor, and the great wheel. And finally, all of them together as a complete train. So now I've got the clock set up with just the escapement wheel and just enough weight to drive the escapement wheel. And what I'm doing is checking the engagement of the pallet arms and adjusting the composer springs, the length of those, to make them engage properly. The other adjustment is the angle of the pallet frame, which is connected to the pendulum. And as the pendulum moves left and right, you can see as it moves to the right, this pallet arm swings in and engages, and the backlash releases that pallet arm. Same thing the other way. When the pendulum moves to the left, this pallet arm engages and releases the other one. And there is just a bit of a problem. This one engages nicely and releases the one on the right, but this one slips. And you can see it slips and disengages before the other one catches it. And this shape of this tooth is incorrect. It's too close to being parallel to the face of the tooth. And what happens is it slips off the tooth. There it goes. So I need to change the shape of that tooth. And after that adjustment was made, it was time to swing the pendulum and let it run. So the tricky bit is done, getting the dual pivot and grasshopper escapement to work. There's a bit of a bounce on the left pivot, so I just need to soften that spring and reduce the balance weight, and that'll fix that. And here it is with the first of the gear wheels added into the train. And it's just been driven by the weight wrapped around the arbor for that next gear wheel. And now with the next gear wheel, which carries the minute hand. The motion works to convert from minutes to hours, and the great wheel are not mounted in the frame yet. I'm still having problems with friction. I think the frame may be distorting slightly, or the bearings may still not be properly aligned. So I'm going to investigate that before I go any further and mount those remaining components. And if I'm going to do that, I'm going to also do some experiments on different styles of bearings to see which performs best. So I'll look at the commercial radial bearings that I'm using at the moment, traditional steel shafts running in burnished brass bushings, micro ceramic bearings, and also synthetic ruby bearings. And we'll see which ones of those perform best, and then I'll install those in the frame. So there we have it. It needs a little bit more work to get it completed, but basically we have a functioning clock. Thanks for watching. I'll see you in the next video.